Welcome to another episode of Learning Mathematics. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We now discuss the solution of a problem from the section Real Analysis that has appeared in the CSIR National Eligibility Test held on December 15, 2019. The given question is related to a polynomial in one variable of odd degree and a continuous function. This question is placed in part C, which is a multiple select question. There can be more than one answer and the question carries 4.75 marks. The question ID is 187-980-1811. This question is suitable for all these examinations. Right. The given question is, let p of x be a polynomial function in one variable of odd degree. P of x be a polynomial function in one variable of odd degree. Please note this. And g be a continuous function from R to R. Then which of the following statements are true? We are given four options. Option 1. There exists a point x0 belongs to R such that p of x0 is equal to g of x0. Option 2. If g is a polynomial function, then there exists, if g is a polynomial function, then there exists an x0 belongs to R such that p of x0 is equal to g of x0. Option 1 and option 2 are same except that g is a polynomial in option 2. Option 3. If g is a bounded function, right, then there exists an x0 belongs to R such that p of x0 is equal to g of x0. Option 4. There exists a unique point x0 belongs to R such that p of x0 is equal to g of x0. Right. So the given question is about a polynomial function in one variable of odd degree and a continuous function g from R to R. And it talks about the common root of p and g. How many are there? Are there any common roots? Etc. Okay. Let's now discuss the solution of the problem in detail. We are given p of x is a polynomial of odd degree and g is a function from R to R which is given to be a continuous function. Call on option 1. There exists a point x0 belongs to R such that p of x0 is equal to g of x0. Not always, not all px and gx. There exists px and gx for whom there is no common root, common value. Let p of x is equal to x plus 1 is a straight line, right? And g from R to R defined by g of x is equal to x. It's again a straight line, right? Clearly, p of x is a polynomial of odd degree 1, right? And g of x is equal to x is identity function, is always continuous. Note that these two are parallel lines, so they do not intersect. There is no common point for these two functions p and g. So these two are parallel and so they do not intersect. Therefore, no point x0 of r will satisfy p of x0 is equal to g of x0. Therefore, for no point x0 of r, we have p of x0 is equal to g of x0. Such a common point is not there. So, the option 1 is not true. We move on to option 2. This time, if g is a polynomial instead of a continuous function, now g is a polynomial, then there exists x0 belongs to r such that p of x0 is equal to g of x0. Now, in the above example, g is considered as g of x is equal to x, is continuous, it's also a polynomial. Every polynomial is continuous function. So we can take the same example and they conclude that there is no common point between them. In the above example, g is a polynomial function and so continuous. We have seen in the above example that there does not exist an element x0 belongs to r such that p of x0 is equal to g of x0. That means x0 is not a common point. Thus, option 2 is not true. We move on to the next option. Option 3. If g is a bounded function, then there exists an x0 belongs to r such that p of x0 is equal to g of x0. P of x is given to be a polynomial of odd degree. Therefore, what is the range of this polynomial p of odd degree? Because of oddness, as x tends to infinity, p of x tends to infinity. As x tends to minus infinity, p of x tends to minus infinity. It all depends upon what is the leading coefficient of the px. Whatever it is, the range of p of x is minus infinity to plus infinity. That means it is a surjective function. Right. P of x is continuous because it is a polynomial. And we know every polynomial is continuous. G of x is a bounded function, meaning there exists capital M greater than 0 such that mod of gx less than or equal to capital M for all x belongs to R. Right. Now, let h of x is equal to p of x minus g of x. Right. And in this, the range of p of x is minus infinity to plus infinity. Gx is bounded between minus m to plus m. What is the range of h of x? The range of h of x is the range of p of x because g of x is bounded. H of x is continuous since px, which is a polynomial, is continuous minus g of x is continuous. The difference of two continuous functions is again a continuous function. Therefore, h of x is continuous. Clearly, the range of h of x is same as the range of p of x, that is minus infinity to plus infinity. Why? Because g of x is bounded. Right. That means the range of h of x is minus infinity to plus infinity means h of x takes both negative values and positive values. Right. Right. And h of x is continuous. We apply intermediate value theorem. By intermediate value theorem, there exists a point at x0 belongs to R such that h of x0 is equal to 0. That much I can say. That is, p of x0 minus g of x0 is equal to 0. That implies p of x0 is equal to g of x0. Right. Thus we have proved the statement 3. Statement 3. Thus option 3 is true. We are left with one more option that we will see in the next slide. Now we go to the fourth option. There exists a unique point x naught belongs to R such that P of x naught is equal to G of x naught. Is the uniqueness is there? There are some polynomials and functions G. They have more than one common points. Think of that one. Let P of x is equal to x cube is a polynomial of odd degree. G from R to R defined by G of x is equal to x is an identity function which is continuous. So clearly P of x is a polynomial of odd degree 3 and G is continuous. Agreed. Now P of x is equal to G of x will imply x cube is equal to x, will imply x cube minus x is equal to 0, will imply x into, in brackets, x square minus 1 is equal to 0. It implies x is equal to 0 and x square minus 1 is equal to 0. That is, x is equal to 0 and x is plus or minus 1. So that means thus P of x and G of x intersect at 3 points, x is equal to 0 and x is equal to plus or minus 1. So which you can see here. So the red one is P of x is equal to x cube, which is a well-known graph. And G of x is equal to x is a straight line passing through the origin making 45 degrees with the x-axis. And the common points are 0, this is plus 1 and this is minus 1. So the option 4 says there exists a unique common point between P and G. But we have seen there are 3 common points. Therefore, our option 4 is not true. Summarizing all the options, the answer to this question is option 3. Right. And that is the detailed discussion of the solution of the given problem. So, as I've been telling you that whenever you look at a problem, what are the concepts and the theorems are used in the example. In this one property that a polynomial of odd degree takes all values minus infinity to plus infinity. That is the crucial point here. And if you are given a g, a continuous function, how many common points are there? And mostly in 3 of the options, you have to use your brain and get the counterexample. And the proof is very, very simple for option 3. With these few words, I say, I am sure that you have understood the solution of this problem. Thank you for watching the video now. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. I am sure we will meet once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.